The role of research in driving economic growth is absolutely fundamental. That's how we generate the resources to build social capital. Our relationship with the EPSRC is one that I value very highly, and one that the university values very highly.
If we want to make our machines faster, our computers faster, the way we transmit information faster, we will have to exploit quantum properties, because the components of the computers, for example, that we're using are becoming smaller and smaller and smaller. What we want to do here in my group is find a way to develop new quantum and relativistic technologies, focusing on the transmission of information. One of the applications that we've been considering is trying to create more precise GPS systems by exploiting quantum properties.
I think framework relationship helps because it ensures that we and EPSRC are actually talking to each other on a regular basis in the whole energy space, in digital economy, in aerospace, in sustainable chemistry, in advanced and innovative manufacturing. These are all really important areas, I think, for the economy, as well as being important areas for EPSRC and the university.
Traditionally, when you're making a component, it may be designed to just looking at the overall shape, something like this. With additive manufacturing, you can really explore the geometric freedoms of parts. You can create topologically optimized, very lightweight components. And the opportunity we have within our EPSRC Centre is to combine some electrical conductivity, biological conductivity, or maybe optical conductivity within the part as you're building it to create the whole system in one go. This is a part that has actually been 3D printed and where we're trying to simulate the embedded functionality within the part. So this has strain gauges and wiring. The reason that this is useful is that it enables you to chunk out whole swathes of manufacturing steps, so you can produce the whole part in one manufacturing operation. We have applications in medical devices, we have applications in aerospace, we have applications in consumer electronics, jewellery, part for your washing machine. I mean, it could take us in many different directions.
We're in a world where the emerging economies are really upping their game. The investments they're putting into science parks, innovation parks, and so on. So it's really important for our economy that we continue to invest in research, because technological progress drives economic growth, and we need economic growth to improve both economic and social well-being.
My name is Dr. Melissa Mather. I'm a Senior Research Fellow at the University of Nottingham and also an EPSRC Career Acceleration Fellow. My work here at the university is based on non-invasive imaging of cells, tissues for diagnostic purposes, and also to help aid biologists. Current techniques like X-rays or sort of MRIs are looking on a bulk tissue level, and they're looking at physical changes in the tissue. But these approaches of molecular and functional imaging are looking at changes in the cells earlier than you see a physical change. So we could perhaps see earlier detection in the diagnostics of cancer on like a molecular level.
The work we do here is mostly related with EPSRC's energy programme. More specifically, my work's involved with carbon capture and storage. We've got two main areas we're working on. The first one is really trying to reduce the cost of the capture process. So what we're doing is working on a range of different capture technologies involving solid materials, sort of adsorbent materials, which can do the separation at potentially do the separation at a much lower energy efficient than the current state-of-the-art technologies. The government's looking at decarbonising electricity generation by 2030, but we also have a large amount of research as well, which is very much more in the short term as well, more applied, which is really aimed at allowing people to build these carbon capture plants really in the 2020s, 2025 and take them forward.
As a lab, what we want to do is reason all the way from sensors to society and think about the digital and its economic and social impacts. Think about how you capture information about people, how that might be understood, how that might be presented to them, how that might impact policies such as privacy, how that may become economically viable, and how business models might emerge from it. Within this lab, we have visiting artists, psychologists, we have sociologists and ethnographers who understand the nature of society. We have people who can build electronic systems and a range of people who can build software systems. And what's been really good from an EPSRC's perspective is that's what they've done. They've backed us as a team and we feel backed as a team. They want us to be different, they want us to be creative, and they want us to keep incredibly talented people together to work as a team and, frankly, to simply do the unexpected.
It's not just about generating growth in the economy for the next quarter or the next 2 quarters so we can say, the recession's over. It's about growth in the next 5 years, 10 years, 20 years. £135 million of investment that EPSRC is making in fundamental research and translational research here in the University of Nottingham will have impact. It will help the growth agenda. And it's important that we recognise nationally that to be competitive, we have to maintain investment in research and development. And my university will continue to play our part in delivering that agenda.